Hello and welcome back to the Code BABM Programming Bootcamp. Hello Laura, how are you?
Hi, good, thank you.
My name is Gabor Sabo, and if you haven't watched earlier videos, then just go back and watch. This time we are going to talk about sets. So it's going to be a short video, I guess, because it's a short chapter. So that's just the main screen, and then this is the sets chapter. We actually saw, I think, a couple of times already. We used sets in exercises here and there, so there's not a huge thing, and I don't even have a special exercise for this. I just wanted to show the general concept. And so sets, I have to reload because I just updated the slides, and sometimes the slides are not updated in the browser. So I took a couple of images from Wikipedia just to show sets, but these sets are just like what you probably learned in school, mathematics, where in case you have things that you only care about the existence of something. You don't care how many there are. So that's usually probably the place where we programmers use sets. And then the nice thing about having sets in Python is that like native sets in Python, that there are all kind of operations that are special operations on sets that Python has functions for them. You could implement the same thing with lists or with dictionaries behind the scene. Actually, I think sets behind the scenes use just the dictionaries where we disregard the value and we only care about the keys, which are unique values. Okay, so this is a Venn diagram, which is one of the main features that people usually look at sets. So here we have a set called A and a set called B, and then you can see what's in both sets or what's in only one of them and only the other one. So these are like the basic operations. Here we have a list of the operations that, or some of the operations at least, that Python sets support with a link to the actual documentation of the sets. But let me show you a couple of examples. So yes, I have to reload because I changed the order of the slides and the browser still remembers the old one. So the first slide is how to create a set, and assuming you already have a list of values and you would like to convert that into a set, here inside I have the list that could have been a variable of a list that has multiple chairs. Here you can chair it multiple times, doesn't matter. When we convert it into a set, the things now, okay, this variable contains an object of type set. If we print it out, we get just the values that's in the set. So each value appears only once, and the order doesn't matter.
How come it's represented by curly braces here?
Yeah, I don't know.
It's not a dictionary though, is it?
No, in a dictionary you would see key value
pairs of, yeah.
Sort of like a list in a dictionary. I guess they ran out of parentheses, yeah.
Types of parentheses, I guess.
I mean, there are all kind of other parentheses in Unicode, but probably they didn't want to use them because
fair enough.
Just hard to type then, or hard to. So maybe I haven't actually tried it. Maybe you can actually even use this syntax to create the set. I'm not sure, never tried it. So maybe you can use things equal to this syntax and then it would create automatically a set. I'm not sure. And if you check what is the type of it, then it will say it's the piece of class set. Okay, and then one of the things that you can do, that's a simple thing, relatively simple thing, is check if some value, which can be actually a variable, is in the set. So the same in operation that we have for lists and dictionaries works, and strings works here as well. The operation is supposed to be O of 1, so it doesn't matter the size of the set because it just checks internally. Similarly, you can create an empty set just by calling set. You don't even have to put in an empty list. You could, you don't put it, doesn't matter. It will create, for whatever reason I call it objects, doesn't matter, whatever, a variable, and then just an empty set. And in this case, I think this is the way Python 3 represents it, or yeah. So the representation is not that clear. It's not that important actually. It's just when you really, when you're debugging your code, then it's going to be interesting. If you have a set, you can add elements to it by calling .add and then giving some value, and it adds the element, assuming it didn't exist there. I mean, if it existed already, then it doesn't really happen anything because it doesn't care. If you have two sets, you can merge them together using the update method. So I actually, yeah, so in this case, in this way, I have the objects and the internals. I add the content of the internal for whatever reason. I call them internal, doesn't matter, just two names. I think they are the celestial objects, the internal ones, in the solar system. That was probably the reason. And then you try to update and you add the new ones to the objects, but the old ones don't duplicate. And
if you do it the other way.
Sorry, my slides got crazy. Sorry. If you do the other way, then you update the internal. Okay, I can't hear you now. But in the meantime, I'll show you this. Okay, so I can't hear you. I hope, I don't know what's going on. But in the meantime, while you're trying to work on it, I'll try to show you the next this example. So merge sets. That was, where is it? It's in the sets. Okay, so in the sets, merge sets by, that was the question. What happens if I do it in the other way? Okay, probably I'm going to hear you. Let's no. I have to create it again because now the objects are, the sets are already updated. So now I'm writing it internal, update, objects. So it's the other way, right? Yeah. And then I print out the objects and the internal. Okay, so the internal is the one that grew now. Okay, it's basically merging the two sets. So the final the results are going to be the same result, but in this time in the internal variable, the variable called internal.
But it doesn't. So the order of the words doesn't change at all, does it?
The order in the output.
Yes.
I don't know if I never checked. I never cared about the order. Okay, so printing like this is really useful only for debugging, I think.
Right.
I mean, I wouldn't use it either way. I only care about, is there an element? Is there the element is in or not?
Right.
So I never. Yeah, you might look it up in the dictionary, in the documentation, but I don't know. But here are the even more interesting parts. The intersection, for example. So, for example, here we have two sets: the English words and Spanish words, just a couple of words, and then you can print them out. Okay, that's fine. But the interesting part is that you can say English.intersection Spanish, and I don't understand. Oh, okay, the slide updated. Okay, so here you can see that this is the intersection. Again, images taken from Wikipedia, from the Venn diagram. The page is linked. So this is the intersection. So these are where elements that are in both. Okay, and we can, if they have two lists, we could easily get this by going over each one of them, and checking whether that element is in the other one. But that would take us a lot more time than using it. I mean, a lot more code and also a lot more time doing it. So that's the intersection. Subset, I can update it, but that doesn't have an image. So a subset would be just checking if the words, okay, which is in this case door and lunar, if all the elements of this are part of the element of one of the sets. So in this case, when I'm checking whether it's subset of English, so there's no, the word of is missing, but that's for sort of what probably should be there. It's true. On the other hand, for Spanish, it's false. Okay. This is what what they usually, I don't know who calls it the ears of the elephant, but that's how I know it. So as if it looks like an elephant on these two sides. Okay, so the elements that are either in this one or in the other one, but not in both. Okay, and all of these things are actually quite rare. I mean, most programming quite rarely needs these things, but it's nice to have them when you do need them. And the union is again when all of the elements, either this one or the other one or both. Okay, that's the union. It's just like this: English, union, Spanish. Okay, and these are both of these operations, that the one we saw earlier and the one we see now, are symmetrical basically. Okay, so it doesn't matter which way you do. Actually, I just tried it because I thought that a plus sign should do the same, and apparently it's not implemented that way. It just gives me a type error. Probably, I don't know, maybe there's an explanation why. My guess is that because it's sort of not adding them together, so that's why it was decided not to implement it. I mean, we could implement it. There's no, I don't see any technical limitation, just maybe the thing that the meaning of this plus might be unclear to some people.
Right. Can you tell me what's the difference between the union and the update method? So before we
the union returns a new set. The update updates one of them.
Right. Okay.
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 Good question. I didn't think that they're actually the same result, but yeah. So the union returns. So the English and the Spanish remain the same, but when we called update, then we updated one of them.
Right. Yeah. Okay.
Okay. And this one is the relative complement, right? Is that when elements that are only one of them, but not in the other. So I can use, and these two, I actually don't know if there is a method for it. I haven't checked it, but you can use the minus sign for it. Okay, maybe there's also a method for it. I haven't checked. Okay, like the union and all the other methods, I'm not sure. Okay, but here is also the direction is important. Okay, and there is also something called in set theory. There's also something called the absolute complement, which would be all of the elements outside of the two. But it's not really relevant for us here. So programming doesn't, because for that you need to define what is everything. Okay, so I don't think that there is anything like that exists in Python.
And I suppose you can do this with as many sets as you want, right? So if you want the intersection of 3 different sets, could you do that?
You mean
like a Venn diagram with 3 circles?
This one, the intersection?
Yeah, that's it.
Interesting. I have no idea if you could give, for example, the intersection a couple of values, or you just have to stack it on one,
right.
like you apparently like it. but you call intersection on the result, and then intersection again, and intersection. I don't know if you could pass several sets to the intersection, or you need to stack them.
Okay.
Never tried. Okay.
Right.
In general, at least personally, I really rarely use sets, but because I think they can be really valuable, and they allow you to save a lot of time when you need them. That's why I'm showing them.
Right.
Okay. Any other questions?
No, I think that's all.
Yeah, so the next chapter is going to be functions, but let's take a break now. Let's stop the video for now. I don't have exercises, so I can come back quite soon to continue with the next episode. So thank you very much for listening, and thank you for your questions. They are always helping clarify things. So thank you, and I'm looking for the button to stop recording. So bye-bye.